everybody here is a dynamic business consultant, but also a business unit owner in some regards. So I'd like for you guys to spend about 30 to 90 seconds talking about who you are and what you do in relation to AI, and a little bit of your background to give an understanding for the audience. Dave, starting with you.
Sure. So I'm Dave Sovey. I'm the global high-tech industry lead for Accenture. And so as it relates to this, my clients have to deal with AI in two ways. One, we call it above the line. How are you going to use AI to change your product and experience to your customer? And secondly, how are you using AI internally to drive out efficiencies in your operations? And so they're both. Anyone that makes a product has got to be thinking about AI as the new UI, as well as is using it internally to drive out cost and efficiency.
Janet.
So my name is Janet, and in my past life, thank you. In my past life, I was processing about 15 petabytes of data in a single day. That's like the entire Library of Congress. That was 10 years ago, before the world called it big data. I was part of Yahoo, and we had to come up with creating new infrastructures to tackle this. Hadoop was born. And we did a lot of data science. Now in Western Digital, we have a similar type of situation. We have IoT, and we have the intersection of IoT and AI. And I've actually, since I've come to Western Digital, I've built a massively parallel distributed computing infrastructure that can do processing of very large-scale data up to multiple petabytes. Year one, I think we did about 2 billion rows of data. Year two, we were 24 billion rows of data. Year three, we were 78 billion rows of data. When you're tackling 78 billion rows of data, I'm telling you, programming falls flat. You cannot do programming. You have to get into data science. You have to get into AI. We'll talk about that a lot more.
Oh, great. Go ahead, Jack. Jack, go ahead.
I'm Jack McCauley, and I'm a faculty member at UC Berkeley, Jacobs Institute for Design Innovation. And my title there is Innovator in Residence, and I teach innovation engineering and invention. Prior to that, I was co-founded Oculus VR in 2012. Prior to that, I was the chief engineer and chief designer of Guitar Hero and a bunch of other video games. Yeah, I'm a video game engineer. Yeah. But I've got a background in thank you. I've got a background in AI with some cursory work I did way back when.
Yeah. They totally gloss over Oculus, but Guitar Hero, man, people are about to like let you fall and carry you out. Yeah, I love it. J.R. Motor, talk a little bit about Iris.
Yeah. Really glad to be here. So I'm founder and CEO of Iris. We do a lot of deep learning-based vision AI, particularly for user behavior understanding through face analytics and facial expression recognition. So emotion recognition and everything else around, anything else that you can understand from the face. We go after two main verticals, autonomous vehicles or semi-autonomous vehicles and social robots. So data is of the utmost importance for us because that's generally how we would train our AI to kind of behave in a way that imitates natural environment. So really glad to be here, and I'm looking forward to this talk.
And Scott.
Yeah, so my name is Scott Noteboom, and probably what brought me to Litbit is I started to lose a little bit of hair running data centers for Apple and Yahoo in my past, and thought that AI maybe could take a little stress away. So past couple years working with Litbit, and the space that we're really focused on is building a human to machine learning interface that uses natural human language, because we see AI personas, custom AI personas, as kind of the apps of the future. But the app developers of the future are actually the people who have the exact subject matter expertise that make these AI persona or coworkers valuable. So what we're really focused on is how can we enable a subject matter expert who's a scientist in a laboratory or a facilities guy cleaning up a facility, a corporate building, to be able to sit in front of an interface, create, name, mentor, and manage their own AI on the subject matter expertise that each of them have, which is different, and then be able to put that AI to work in varying places around the world or any place in their environment. And we see as those AIs are developed, these personas that have particular skill sets will become apps of the future that people can subscribe to and share with other people and really kind of help humans in the workplace going forward.
No, that's great. You know, just to kind of build a shared experience. I mean, there's it was a great presentation from Accenture that highlighted a lot of like major and interesting issues. And one of those again was like it's like there's so many people that know they got something to do, and there's so many people that are like, oh my God, where do I even begin? I hope that I can like get a new marketing buzzword. When was cloud awesome? Remember when cloud was like hard to understand? It's like, no, it's just a bunch of servers that are just not yours. I mean, so here we are, we're sitting on this precipice, right, of all these like impending changes, and a CEO is telling the technical team, data is the new oil, because that sounds great in a boardroom. Like, how do you even begin to refine it? Like there's stages of POC, there's stages of slide deck, and there's stages of stuff that's actually in market, I think. What are some just baseline, like good understanding or some basic rule of thumb navigating this situation now? Maybe mobile, you were there with mobile or something else. Like, what are just some things that you can throw out there initially for some people to glean?
I'm happy to start.
Yeah.
We always try to encourage people, you've got to be out there experimenting. So first, I think everyone in the room knows AI is not one thing. It's really a basket of a range of technologies. But you've got to actually start with the use case that's a business problem that's going to create an economic benefit and not just kind of cool technology to do something. And the reality is there's a wide range of those use cases, and many of which are not quite ready for prime time. But if you don't start doing the proof of concepts to prove the business value first, and also demonstrate the right mix of technologies to apply to that business problem. So I mean, we are definitely encouraging people, you need to be out there experimenting. You need to be doing a range of proof of concepts, but make sure you start the proof of concept with a theory of the case of what's the economic benefit and the business outcome you're going to drive, either for improving your internal operations or improving your customer experience. Because it's very easy to get carried away with the technology, because the pace of the technology innovation is astounding. It really is astounding. But if it just leads with the technology, you're going to find yourself having spent a lot of money, maybe not delivered the business outcome that your CEO is looking for, your CFO is looking for.
And Janet, you have examples or customer examples you're thinking of?
I would add to the comment here, but I would say stop prototyping and unite your data quickly. Because here's an example. S1, sample 1, R1, result 1, S2, sample 2, R2, result 2, S3, sample 3, R3, result 3. You're going to take these 3 results. Which one are you going to pick? How are you going to decide? What are you going to retrain or train again, right? So combine S1, S2, S3 very quickly and look at what R4 looks like after the combination. Unite your data. AI is about scale. You're going to see very different facets of the data if you apply AI to small sample sets. Start prototyping because you want to learn, but quickly go from prototyping to amassing large amounts of data. That includes structured, unstructured, and semi-structured data. Until you amass this data at scale, you're not going to be able to discern the signals, or you're not going to be able to discern value from that data that will actually materially be able to be impactful. You need results that you can go to manufacturing and say, machine learning can do this for you very substantially. In order to show that, you need to be able to do prototyping at scale or AI modeling at scale.
So that's Right to you, JR, because like you guys are an application that's focused around data. You guys had to just crack and get to market, right?
That's
you were
right.
funded. You don't get to like POC in the sky forever, or your investors get upset with you, I bet.
Yeah,
So,
we get right down to it. So just before I comment on your recent comments, I wanted to add something to your initial question, which is how do companies need to probably tackle or start utilizing AI? And I think the first thing is for them to identify where is the problem, and if there is no problem, where can they improve business processes? Because obviously everybody has a lot of data. And the second thing is where there are opportunities, business opportunities from which they can create new products from either existing data or from the convolution of all the data using AI. And I think the example earlier was great because Siemens does use the first one where they improve their internal processes. And then the second example that was given also was for Uber, that's actually using all of the data to actually not only improve the service, but to create new opportunities and new products. So these two kind of categories are extremely important to identify at first. Before you can even have an AI strategy, what do I want to do? Do I want to improve business processes or just create new product, right? It's because the data is there and you can go and amass it. And obviously, we can go through the training and all of that. That's a different conversation. Now, when it comes to identifying, small use case, our use case, we have no business processes. We just need to create a product. We just collect a lot of data from natural environments, vision data, from as many corner cases as possible. That was also something that was a question that was asked earlier. How do you make sure AI is well trained? But you just amass as many corner cases as possible. Try to imagine them, and the more you run these tests and these data collection tasks, the more you come across corner cases that AI could benefit from. And literally, have a team of data annotators, because when we talk about AI today, really important that we talk about deep learning, and when we talk about deep learning, we talk about supervised learning. So until there is unsupervised learning, code that writes its own code and things like that, we're still at the mercy of these guys that annotates and label the data. And we're still at the mercy of their biases, gender biases and thinking biases and all of these things. But so what we do is just collect a lot of data, a lot of corner cases, and train the data, annotate it, and hand deliver customized models to our customers based on their specific environments, specific applications, specific vehicle, hardware, camera position, lighting conditions, et cetera, et cetera.
So that just to kind of follow it up, just to drill down a little bit. When you're going and selling some of your earliest applications and stuff like that, getting the CTOs adopt and create some of those earlier processes. No one was doing that, I mean, how were you guys able to push that and come up with the business cases to actually implement and drive that to market with your partners?
So we really had to understand what the problem was and what the customer's need was initially. And obviously, generally, it boils down to I want this magical solution, and I want it cheaper, and I want it to work on as many, for as many things as possible.
Yeah.
That's generally kind of a rule of thumb for anybody that wants a solution. We worked together on identifying cost, timeline, and what does it mean for them to have that kind of solution. A great way to improve your AI, or maybe for a startup, at least for us, is to kind of suggest these non-recurring engineering projects where you'd go on a 3-month project with the customer and tell them, okay, you want this, we can achieve it, let's work together. You can give me some data, I can also produce some data, and then together we can come up with a solution. That, by the way, will be your exclusive kind of solution. But at the same time, it is something that we can leverage for our own internal kind of AI strategy, if you would, to better our code base and to better our technology as a whole.
So on this, because I'm really trying to drill down into understanding the executive mindset that's out there and how we can push people through their, Scott, seeing some of these things, what are you seeing the trigger points to bring something from just, hey, here's a pitch in a boardroom to, hey, this is a real tangible implementation that the team has a win that's around AI. Have you seen?
Yeah, so I've started to talk to those 90% of executives that have a strategy, and what I really find is most people that I talk to have a difficult understanding of what AI means. And one of the things that doesn't help it is some of the smartest engineers in the world have been working on AI for the past 60 years. And many of those smart engineers, frankly, have been professionally trained to think like a computer. And many of them have a difficult time relating to AI from a humanistic approach. So usually when the first thing that I try to do in these executives, because I make an assumption that they don't really know what it means, is to try to connect to them in a very human means. Explain to them that an AI and supervised learning, I don't even use the term, but teaching and mentoring the AIs is all about you and your experience. And we use the term coworker because the more that I can get the executive to think, okay, we can develop someone with an expertise of Joe, and Joe doesn't exist in Chengdu, China, where I need to deploy that expertise. I can relate to that. I can relate to, recruiting, jobs that people I can't find skill sets, dangerous jobs that people shouldn't do. And if you get them to think about it from a human perspective, then you've cracked the first kind of hurdle of being threatened by it, not understanding it, and then you can start to begin like a meaningful conversation.
So like AI is engineers' way to get us just to be more intimate with machines. I mean, essentially, like a lot of AI is just this human integration that we're seeing, and that makes it, kind of tough to sell that in the boardroom, right? I mean, kind of across the board, because we want solutions that are hard, that are 5 nines. And solutions integrated with people are not 5 nines, right? I mean, we talked a little bit about that. Jack, when you guys started thinking about AI and the load there, early days with Oculus, what were some of the issues that you guys came up with, or what were some of the edge use cases that you guys looked at? Was it collaborative or not?
We didn't look at AI.
Okay. Well, good, not everybody can, right?
We were looking at video games. I started hearing the term deep learning a couple years ago, and I'm going, what deep learning, what does that mean? I went on Wikipedia, and that's usually where I get my information. Don't trust that source. It's not very good. And I said, it's deep learning is neural networks. I go, oh, I know neural networks because I took courses in that in school. And so I endeavored to try to explain to people who, or not laymen, but technical people, what it is, but with a quick presentation. And I tried my presentation out at a talk in front of a group, an audience like this, and I started walking my way through the slide deck, and I was looking at people, and they're all looking at their cell phone by the 6th slide. Or one guy was looking at me, his eyes were closed. Anyways, it's not used in the video gaming world and to any great extent. And the reason is that applying a learning algorithm to a particular player when it's a multiplayer game may give that player an advantage. And it's most of that stuff, in video game stuff is table-driven stuff. There was a company that approached me about 6 months ago and says, we're going to create avatars, which are video game avatars, which are AI-based. And so you would play an avatar who's actually an AI avatar. And the answer to that is that people like Microsoft and Sony want to build their own stuff. They wouldn't be inclined to buy that from someone, and that's just the way the business is. And neural networks, and from the data the information I had and academic people is that there wasn't enough computing power to really manage it back then. The computers were too slow, but they're not so slow now. And you have a GPU, which comes from video game world, it really does. And GPUs are very good at doing matrix multiplication, which is used in AI. So, I say that, we don't use it in a video game, but it's kind of the other way around. AI uses our stuff. You talked, Janet, you talked about, I was listening to what you said, and you talked about managing data. The other thing that's coming out of the video game world I think is relevant right now, it's not exactly AI, but it is a data issue, is localization. And in VR, we use localization to create an artificial world you can walk around in. And one company's done a particularly good job on it, and they're using a technology called SLAM. And SLAM is simultaneous localization and mapping. In other words, you can walk into a room like this and instantly map the room, the depth, all the features of the room, including the people sitting here, so that the next person that comes in, he already has the map available to him. When you walk into the room, it doesn't exactly instantly do that. It maps it. It takes some time, but that data is stored. Now, what application does that have? It has an application in self-driving vehicles, autonomous vehicles for mapping parking lots, roadways, other features that you may drive into. The vehicle ahead of you can map the highway or the road that you're driving on, that you're going to be driving on. It entails a lot of things, particularly with IoT. How do you transfer the data from one vehicle's mesh of the world to the?
So like context. I mean, essentially, like everything I hear people talk about with AI is always context.
Yeah.
It's always context, and the more you understand of context, the more you understand of things. I mean, it's just that's the definition of understanding context. Just to kind of key it off, because we're running out of time. It drives me crazy because there's so much stuff I want to talk about on this panel. What do you see as the biggest barriers and challenges for technologists to overcome in order to get this implemented in terms of AI? We can start with, let's go with Scott, you on this side.
Yeah, probably the biggest challenge we have is when we put the ability for someone to teach or train an AI in their hand, and they're spending the day, a lot of people will say, well, how can you get a normal person to quickly recognize what a Gidget-Gadget is that's not in the Inception system by Google? And what we do is we do things like we have to fool the user and go, well, you can train it in a single lesson. Well, how do you do that? You take a 1-minute video at different directions, which actually ends up being 1,800 pieces of training across the minute. But the bottom line is as people throughout their day continuously are training the system, and we're seeing that level of engagement, which is awesome. But what they want is again, thinking in human terms, well, if I hire Joe here and I tell Joe that, this here is a gimme gadget, and then I'm going to say, Joe, what is this? And I'm expecting Joe to say it's a gimme gadget. So rebuilding the models, which are incredibly compute intense, which we always do at the cloud, and then we distribute the models down where the scoring best makes sense, whether it's on-premise or on the cloud, is incredibly compute intense. And people are expecting or will expect it to occur instantly. And we still, we talked about, and one of the reasons I started the company is being involved in building these big clouds. I could see it in front of my eyes, like, what do you need for AI to work? Since it's, the term came out in 1956. You need big, distributed, low-cost compute. You need an Internet of Things and AI without senses is not connected to the physical world. You need, and my mind is blanking now, all the things that you need kind of are there to make sense, but you need to be able to apply that teaching and put it in production really fast. So, 2 hours is not fast enough, and we're using massive GPU resources.
5 more minutes to blanking, and then we can all have drinks. We all blank out. Yeah, I appreciate it. Go ahead.
I can put the challenges in 3 different buckets. These buckets are actually what makes AI or what makes us talk about AI today, and those are data, processing, and the third one is the training, which previous presentation was on. So the data sounds like it's there, but there's still a lot of data that's not there because mapping the world is a tough thing to do. Processing seems to be kind of resolved now with GPUs, but then GPUs are not a great solution to deploy a $100 social robots, right? And the GPU itself costs more than that. If you have an AI that's trained on GPU that doesn't necessarily or cannot necessarily run, or you cannot run the entire network on cheap processors like a Raspberry Pi type of thing. And then the third thing is training, right? Training pertains particularly, and I put a lot of weight on training because it pertains particularly to supervised training, to the only method that allows us today to talk about AI, which is supervised, right? Whether through reinforcements or any of these methods and means and architectures. And I think we can still solve some data because some cases may have a lot of data, and it's not a challenge. And in some cases, processing is not a challenge because NVIDIA's signing deals with everybody now, all the car companies, and it sounds like these cars are going to be powerful enough, and they have GPUs. So if you have something trained on GPUs, then it's not a problem if you want to run it on a car. And I think, like I said, I can put a lot of weight on the training piece of it. That's kind of still daunting, redundant, requires a lot of human power, right? Which is the reason why a lot of these annotation companies are kind of doing really well today, but then that can automatically change in a second once the next great paper comes out and some great university that says, hey, we have the solution for unsupervised training or semi-unsupervised training. Then I think that would be less of a challenge, and then I think that's what will prepare us for artificial general intelligence and therefore artificial superintelligence.
Jack?
Sorry. How many people know what a GPU is here? Oh, quite a few, okay. I didn't explain what that was.
I feel better. I mean, I mentioned it multiple times here.
They all raised their hands. They all wanted deeper, so we're all right.
Yeah, that's a graphics processing unit, and what it does is matrix multiplication and shading and things like that that are used in gaming, and also CAD and so forth. If I were to endeavor to do another startup company right now, I would endeavor to do something with what I mentioned previously, which is SLAM. And I know it doesn't involve artificial intelligence now, but and that's what I would do, because I think that is being able to have a map of the, I mean, Google Maps, right? It has a 2D view of the world, a sort of 3D-ish thing, but if you had knowledge of what the world looked like and were able to utilize that to sell things, and also just for informational purposes, I think that's very high value. Of course, I'm not going to do a startup again, but I won't. As far as AI goes, I don't claim to be an expert in AI, but I'm a generalist more than anything else. When I heard the deep learning thing, I started looking into it, and I go, oh yeah, like pattern recognition, color recognition, things like that. It makes a lot of sense to me. So thanks.
Yeah. Janet?
I think that we came from a world where we took our data and we structured it and we used it for specific things we wanted to know from that data, BI, queries. All our data was structured for querying. So now we've suddenly introduced a brand new paradigm. We said AI. Where's our data? Our data is the data that we structured and crunched and munched into for this business intelligence. So we have to reimagine what is the data we require for doing actual AI. And for that, we need not just the data, we need a different infrastructure. So different infrastructure, different data, and then we got to start applying all of the different formats that we have from different kinds and types of data, structured, unstructured, semi-structured. Then you actually apply AI on top of that. Traditional stacks like the Hadoop and Hive, for example, Hive was built to handle 10,000 rows. After that, it falls flat. Then you go into HBase, and you're constantly trying to fight this stack and this platform model. These platforms have to be highly flexible and give way to GPUs and CUDA stack. Now, CUDA stack is not evolved. I'm experimenting with it right now, right? But we'll see the evolution come up. This is the challenge for AI. As we go into, we got to rethink how we collect our data, what the rawest form of data that we pick from the industrial internet, IIoT, and then what transformations that data goes through, how it's applied, what formats do we come up with, how do we store this data, and then how do we ultimately use that data for massive training and massive learning.
I appreciate it. Dave, you want to bring us home?
Yeah, sure. If I take the challenge from a slightly different angle, let's assume I'm a CEO of a large global company. I actually believe the technical challenges are going to be solved or in the process of being solved, and there's people in this room that are going to contribute to doing that. I think the technology is way ahead of the human equation on this right now. And if you're an enterprise CEO, how do you have to think about the workforce of the future? What are the new types of skills and job descriptions you need? What do you think about the fact that you may be automating 10, 20,000 jobs? What is the evolution of the career path for those individuals? What are the new skill sets you need inside of a company? And that impacts every function. So if I'm the head of supply chain, I'm the head of engineering, I'm the head of customer service, I think we're just way behind in thinking through the human implication of this still, as a company, as a society.
It's quality versus quantity, right? What are you doing to minimize that data, or maybe you'd call it mining? to actually achieve what you want with the minimalist amount of data as possible. I'm a power electronics guy. I'm at least 10 kilobits
we're
in.
so obsessed over like quantities of data, where the reality is we don't worry about that because our minds take care of it, so we don't have to obsess over it. And you could call it insights, but it's our mind's processing that makes that value, whatever it is, I don't pay attention to it, I've looked at it, much less relevant than what we're talking about in the technology space. That's the job of AI. The job of AI is that we shouldn't be talking about, the average Twitter user tweets 1.6 times a second, and I've got a machine that tweets 87,600 times a minute, whatever. Your point is very well taken, because that's a major initiative of AI, because there's already too much data. Who cares if it's 10x bigger? We already can't comprehend it.
So if we are going to connect so many things, and there's going to be trillions of sensors, and everybody's going to be connecting everything in the enterprise, eventually isn't it that a scenario where people can't afford to connect so many things anymore?
I'll take this. So think about not having data or not having ability to train AI models, and your programming paradigms not scaling with the amount of data that's coming, right? So this is why initially, at least, we need data lakes. We need to unite data. We need to bring as much data together so it forms a basis for training. Once we've trained it, our data cannot scale at the rate compute and data will not keep pace. For example, data will be a lot more than compute will be. This is where architectures will get very clever in the stack. And even in our own architecture, we're looking at how do we promote the right data from the data lake into the compute stack so the compute can address that data. What data do we need to demote that doesn't need to be in the compute stack, right? And these are the kind of architectural shifts. This is what our human brain does on a regular basis, right? We can discern very quickly as we come into this room how we've had years of training data, right? But if you don't have that training data, how will you then go create these models? So it's a catch-22. You need to amass large amounts of data simply for training. And then once the models get better, then you just incrementally train the model with the variations, the variability or the nuances or the outliers, if you will.